In everyday life, we often have to work out sums in our head. For example, when shopping, to work out the price or check the change. In Germany, while doing this, people will often murmur, according to Adam Ries, that comes to... At the start of the modern age, in around 1500, most people still couldn't calculate. At markets, for example, all sorts of currencies were in use, but most people lacked the knowledge to check the merchant's price. All this was changed by one man, Adam Ries, who made arithmetic accessible to all. He's better known in Germany, his native land, as Adam Ries. Adam Ries was born in Staffelstein near Bamberg in southern Germany in 1492. His parents sent him to a good school where he also learned Latin and geometry, the most important accomplishments for an educated citizen at the time. Adam lost his father at the age of 14 and set out on his travels, because his father's inheritance had gone to his children from a previous marriage. In 1515, he arrived in Erfurt, where he settled down. Erfurt in those days was an important centre of the humanistic movement. One of the main aims of the movement was to improve the education of the general populace. For this purpose, the humanists said books should be written in German and not in Latin, as was usual. Erfurt was already one of the first cities in northern and central Germany to have modern printing presses. Here, books could be produced in large editions, using the technology invented by Gutenberg. For example, at the sign of the Black Horn, where books by Martin Luther were printed, and soon books by Adam Ries too. In 1518, Ries's first book was published here in German. Its title means Calculating on the Line. This was a reference to the abacus. The abacus is a mechanical aid to arithmetic. It's used to this day in Japan, China and Russia. Its name probably comes from the Phoenician word abak, which means dust or sand. In other words, the dust or sand in which you could write. Because before the Babylonians invented the wooden frame with movable beads a good 5,000 years ago, pebbles on lines drawn in the sand fulfilled the same purpose. The Romans had a pocket calculator, or rather pocket abacus, made of metal. The movable buttons were called calculi, hence our word calculate. The abacus was also known in Germany, and it formed the basis for the counting boards used by Adam Ries. So-called counting pennies were moved around this board. In this way, pupils learnt to read off the result of a calculation simply by counting the pennies on the lines. In Ries's day, Roman numerals were still in use. These were letters of the alphabet. I for 1, V for 5, X for 10, L for 50, C for 100, D for 500, and M for 1,000. The number represented here consists of the letters for 1,000, 500, 100, 50, 10 and 1. Add them together and you get 1,666. These letters determine the subdivision of Ries's counting boards. The horizontal lines from bottom to top represent the units, tens, hundreds and thousands. The thousands line is marked with a cross. The spaces between the lines represent the values 5, 50 and 500 respectively. Between a line and the next space up, the value of a penny therefore increases by a factor of 5. Between a space and the next line up, by a factor of 2. Vertical lines divide the board into separate boxes for the different numbers involved in a calculation. These are displayed on the board using the counting pennies. If we now have 5 pennies lying along a line, they're replaced by 1 penny in the next space up. Because 5 times 1 is the same as 1 times 5, so 1 penny in the 5 space is the same as 5 in the 1 space. In the same way, 2 5s are 10, in other words, 1 penny on the tens line, the next line up. After completing this procedure known as lifting, we have 1 penny on the hundreds line, 2 on the tens line, and 1 on the units line, in other words, 121. To perform an addition, we add the second number to the adjacent box, for example, 92. In Roman numerals, it consists of an L or 50, 4 X's or 10s, and 2 I's or 1s. After the pennies are laid out, they're pushed across to join those in the left-hand box. Now the number is simplified once more by lifting. 5 of the 6 pennies on the tens line are replaced by 1 in the 50 space. We now have 2 there, so they can be replaced by 1 on the 100s line. Now we can simply read off the result. 2 hundreds, 1 10 and 3 1s. 213. In Roman numerals, that's CCXIII. Ries wanted to make it possible for everyone to calculate correctly. No one was to be cheated anymore. He wrote a book in which he started from first principles and proceeded to more complex matters, a sound teaching method. He explained how to solve everyday problems of arithmetic without resort to higher mathematics. In 1522, Adam Ries left Erfurt for Annaberg. With a population of 8,000, Annaberg in those days was the second biggest town in Saxony. It was bigger than Leipzig or even Dresden, the capital. Ries took the citizen's oath and started a family. Then he bought a house on Johannesgasse, where he established a school of arithmetic. As he had already done in Erfurt, he taught ordinary people to use the counting board. It can also be used for multiplication and division. Multiplication goes like this. Lay out one number in 2 boxes. In our example, a 10, a 5 and 2 1s. In other words, 17. The second number to be multiplied, in our case 13, is mentally divided up into 10 and 3. First, the 17 in the first box is multiplied by 10. That means the pennies are pushed up to the next space, times 5, and then to the next line, times 2. To multiply the 17 by 3 in the second box means adding another 2 lots of 17. So now we have 3 lots of 17. Now all the pennies are moved to the left-hand box. Finally, we apply the lifting procedure to simplify. 5 pennies on the units line are replaced by 1 in the 5 space. Each set of 2 in the 5 space is replaced by 1 on the tens line. Then 5 on the tens line are replaced by 1 in the 50 space. Finally, the 2 in the 50 space are replaced by 1 on the hundreds line. The result? CCXXI, in other words, 221. Similarly, Adam Ries performed division by a series of repeated subtractions. Arithmetic using the board was simple. After all you had to do was shift the pennies around, though of course you did need to be able to count, but the procedure had 2 downsides. First, it has no memory. Once a penny is moved, the process cannot be reconstructed. And second, you had to have the board and the pennies with you. Calculating with Roman numerals alone without some mechanical aid is almost impossible. Unlike our decimal system, it is not consistent throughout. Ries recognized the problem and realized that the so-called Arabic numbers, where the value of a symbol depends on its place in the sequence, provided a means of solving more complex arithmetical problems. The Arabic numerals had been known in Europe for some 700 years, since about 800 AD, but they'd not been used for calculations. Especially the zero, originally thought up in India, was suspect to many people. By itself it means literally nothing, but if you attach it to other figures, their original value is multiplied by 10. The Arabic numerals and calculating methods were declared to be the work of the devil. At around the turn of the first millennium, Pope Sylvester II did try to popularize their use, but even he had no success. Ries, by contrast, did succeed in making the Arabic numerals respectable, above all because they liberated calculations from the counting board. This major step forward, calculating on paper with Arabic numerals, was described by Adam Ries in his second book, Calculating on Lines with a Pen, which appeared in 1522. Adam Ries earned his living as a miner with a pen. In other words, he had a desk job administering the revenues of the productive silver mines in the Duchy of Saxony. On the side, he continued to write books aimed at instructing ordinary people in the principles of arithmetic. In 1533, he wrote the Annaberg Bread Regulations, a book of tables. It told bakers how big a loaf had to be if it was to be sold for a standard price, despite the fluctuating price of flour. In 1550, he published a longer version of his book on performing calculations with pen and paper. He had in fact written it 25 years earlier, but at that time he had no money to print it. Then, Duke Moritz of Saxony advanced him the cash. One other important work by Adam Ries remained unpublished for centuries. Entitled Cos, it was preserved in manuscript form and represents one of the first textbooks on algebra to be written in German. The title comes from the Latin word causa, which means thing or affair. It refers to the unknown quantity in an equation, in other words, what we would today represent as x. For a long time, the manuscript was thought to be lost. An annotated facsimile was not published until 1992, 450 years after the text was written. Adam Ries died in Annaberg in 1559. His contemporaries lost not only a great arithmetician and teacher, but also a committed humanist, who can, with some justice, be seen as the Martin Luther of mathematics. The quality of his didactic approach is demonstrated by the success of his textbooks. His second work was used throughout German-speaking Europe for more than 200 years, and had gone through at least 112 editions by 1656. And, not least, the name Adam Ries has gone down in German folk memory.